NC, founder and CMD of SSA group of companies. Over a period of time, we recognized that there is one important area of the business model which has been uncovered is the product development process. NPA Lean is the thought leadership of SSA, wherein we wanted to apply the Lean concepts for the entire new product development process, commencing from the customer need identification till the product is successfully launched in the market. One of the tools that is used in the NPA Lean is DFMA, which stands for Design for Manufacture and Assembly. A DFMA is a technique which was born in Lucas, UK in the early 80s and which has become a developed science at this point in time. What DFMA does is, it gives you an opportunity to evaluate the design efficiency of the product at the early stage. Another aspect of DFMA is also looks at the suitability of the product design for assembly. So design for assembly is also one of the technique which is used in the NPA Lean, which gives you an opportunity that how far the product design is suitable for manufacture. So with these two techniques as an example, there are many number of such tools are used in NPA Lean. So the product is made lean not only with respect to the wasteful activities but also with respect to the number of components in the design. That explains the example of NPA Lean is. So SSA Techknowlogy has positioned itself to cater to this requirement of building this nation by developing our designers.
So if you see today in the Indian scenario, there is over the last 20 years, if you would see from 1990 when we got liberalized, from that point on, a lot of joint ventures have happened, and this is taking on from the automotive sector. So a lot of automotive suppliers, tier 1, tier 2, there's a lot of dependency on collaborators design. Second, designers focus more on the functional aspect of it and less on the manufacturability aspect or on the packaging aspect or any of the other aspects. And the focus is how is the intended function going to be delivered. Third, verification validation is not structured. And lastly, they are not concerned about customer latent needs. In the end, what happens is the quality of design suffers. When the new product is being designed, there are various elements which drive the cost of the product. So it might seem as though the designer has to know all kind of a situation, and typically what we are trying to get into the Indian scenario is that the designer's competencies or knowledge level should be broad-based in many areas and has to be functionally focused in some areas in terms of getting the design right and making the design right ready for manufacturability first time. So when we get into the value engineering paradigm, we are going to look at how are we going to reduce cost, how are we going to deliver value to the end customer. A typical traditional approach would go with the functional design, try it with the customer may accept or reject it. If he rejects it, then you get into a value engineering mode or value analysis mode and then try to reduce the cost and again make it up with the customer. This has been the traditional approach in our most of the organizations, if not all. So what we are going to get into is the value engineering methodology, where the philosophy is the value which is delivered in the end product is greater than the cost involved to manufacture it. Second, the methodology about how we are going to deliver it. Traditional value engineering methodology suggests a 7-phase approach in which we deliver it. SSA has given a different phase modules in the form of a DMAIC, taking away from the Six Sigma methodology and then deliver the same value engineering methodology. And then some of the tools and techniques which are used is the fast diagram, which is the functional analysis and system technique. So if you see the value engineering DMAIC approach, last time I'm going to quickly go through it. What we seen last time is the value concept, which was presented by Michael Harry, is that value is a function of the utility of the product or a particular component, the convenience to use it, the acceptable life of the product, and is inversely functional to the cost of the product. So just to take a differentiation of what we are trying to achieve with the DMAIC methodology is, one, reduce the number of phases which are going to be involved into the creation of this whole methodology. So reduce it from 8 phases to a 5-phase approach. In the traditional value analysis, value engineering, structured customer inputs and analysis is typically missing. So what we have done is included a VOC to CTQ drill down as part of the value engineering methodology. Second, the value is primarily based on cost alone, and what we have defined is value based on worth to cost ratio. Design for functionality base is the primary basis in the traditional approach. Again, what we want to bring in is design for the complete product life, right from material manufacturing, packaging, logistics, installation, maintenance, and then disposal. And lastly, the analysis phase, and this is typically in the value analysis area, for identifying the key causes for high worth cost ratios. So in the recognized phase, what we are going to do is identify the right product on which has to be value engineered. So how are we going to select the right product, which is going to be based on its ability to add value to the stakeholders. Second, in the define phase roadmap, what we are doing is getting the voice of the customer, drilling it to the CTQs is the primary aim of the define phase. We are ready to get to the next phase, which is the measure phase, which is where we will baseline the product, and it is a quantified worth to cost ratio. And then once those are prioritized, we can take the key areas and functions for analysis. Finally, we get into the analyze phase to identify what has resulted into these problems. And when you look at the value ratio and the worth to cost ratio in ascending order, this is where we will identify all the re-engineering opportunities, and if it is greater than 1, we take it up for improvements, where we can and tabulate the problem areas, get the YY analysis done, and once we have prioritized this list, again get those approved for taking it ahead for doing the design changes. Improve phase traditionally is more on brainstorming. We'll have various tools of brainstorming which are going to be consistent, be it TRIZ, or you might do 6 thinking hats, and these kind of technologies is what you would use in terms of the improve phase. And lastly, in the control phase, we want to sustain the benefits of value engineering and continuously do the standardization and improvement. That being the goal of the control phase, similar to the audit phase in the traditional approach. So that is all I had in terms of the value engineering the DMAIC way, which I had to present. So I'll open the table back to Pradeep for some questions answer sessions.
Thank you, Ganesh. It was thought-provoking. The question is, functional block diagram or fast diagram is used in which phase of value engineering DMAIC? Is it define, measure, analyze, improve, or control? The answer is B, measure. I believe only 11% of you have answered rightly. So we are quickly going to the next question. What is the baseline metric to improve value in value engineering? Is it cost, worth, or customer importance, or worth to cost ratio? It is 91%. You have selected yes, right. It's worth to cost ratio. Thank you very much. Before we proceed, I would like to say that we do have a Design Excellence 2013 as a web symposium wherein we are calling for all the papers in cost reduction projects. Please contact me. My email ID is pradeepb@ssa-tech.com for more information. Thank you very much. Over to you, Mrunal.
Good evening, gentlemen. This is Mrunal, and I am going to present the webinar on design to cost today. So what exactly is design to cost? Design to cost is you want to design a product which will have a lower cost. So you can have the controls of lowering the cost of your product in the design stage itself. Now how can you do it? One of the method which you have already seen is through value engineering. The other method that I am going to walk you through today is DFMA. That's design for manufacture and assembly. The primary objective that anybody would want to go through DFMA is reduce the product cost. How will you reduce the cost of the product through DFMA is, you will want to reduce the cost of the product by reducing the number of parts that are there in this product. As you can see in this example here, this part is made up of 4 different parts. If you apply DFMA, it has been molded into one single part. So this is the power of DFMA, to reduce the number of parts. That's the another primary objective of DFMA. The third objective of DFMA is standardization of parts, where you want to apply standardization across all product families and product lines. The fourth one being design for easy assembly, and you want to design the parts for easy manufacturing. So the question here is, where do we exactly apply DFMA? Where does DFMA come into place? So DFMA comes into place in the concept generation and detailed design phase. In the concept generation phase, you will have a fair clarity of how many number of parts are there in my product. That time you can apply the first level of DFMA. In the detailed design phase, where you have fair clarity on the dimensions, the shape of the parts used in your product assembly, you will apply the second level of DFMA. So the first part till functional analysis is called DFM, and the second part is called DFA. Together this constitutes a part of the lean manufacturing system. If you can see the figures, on the left hand side I have a part which is made up of single part, and this right hand side product is made up of 2 parts. If we ask any traditional engineer, he'll say which part is more economical to make. Common answer that we get is use the right hand side figure, which has 2 parts. Since this left hand side 1 part material will result in a lot of scrap in the strip layout that is designed for the sheet metal press tools. So my friends, DFMA should be ideally looked towards application in your new product design and development projects. Since this will not only reduce the cost of your product, but it will also give you an out of the box thinking and keep in pace with the latest technologies that are available. Let's quickly look through some of the common examples that have been applied. A very well known example, earlier bike wheels rim had spokes and these wheels made up of approximately 110 parts. It was made into a single pressure die cast rim. So you can see from 110 parts it was reduced to only 1 part. This is a typical fan that was used. It has flanges, it has fasteners, couplings made up of 12 parts. They made step and they increased the dimension on the flange. They press fitted it and made it from 12 to 3. Now I hand it over to Pradeep for further questions and rounds.
Thank you very much, Mrunal. So we'll be having a panel discussion. Yes, Mr. Shriram, please go ahead. Thank you.
Yeah, thank you for this opportunity. I think the objective of any business is eventually to make profits by ensuring that your customers are eventually satisfied. When you design a product, and when I look at it, profitability as a CEO, I look at things 2 ways. One is cost, as we have walked through today. But when you look at cost, there is a cost that we incur as a manufacturer of a product. There is also a cost that we incur from the customer side. A customer pays a huge amount of money to buy the product, but he also pays a huge amount of money through the lifetime of the product in terms of either spare parts or in terms of servicing or in terms of even downtime of the particular product. How well you incorporate that aspect of the customer's cost into your product design can actually help you increase tremendously the value that you offer to the customer. The way you interact with the customer base via your marketing teams and with the design teams, and how much of the features can you incorporate into the product design itself can actually help you bring down cost substantially. The other dimension that I would like to bring into the audience's perspective is also to look at the price that a customer pays. Oftentimes we look at profit as just a subtraction of the price minus the cost. It is not necessarily so. A price is a monetary value that a customer pays on par with the value that he perceives. There are often cases of a customer not having perceived the full value of your product. So the way we dialogue with the customer to help him understand the clear value of the product. Many times the customer has a stated need, at times he has an unstated need as well. The more you visualize this and help the customer understand, he is able to pay you a better price. So if you can actually do what is called value selling, in addition to the design process of bringing down cost, the ability of a company to make more profits, it goes up infinitely. So what I want to say is that on one side we have to improve our design processes to ensure that the cost comes down of the product itself. The lifetime cost has to come down so that the cost that we as a manufacturer incur or the cost that a customer incurs to maintain the product is substantially lower. And on the other side, we have to increase the value that you offer to the customer, either by meeting his stated and unstated needs or even helping the customer realize the needs that we are actually helping him meet.
This is Prashant. I'd like to just first say that I fully support what my previous panelists spoke about, broadening the gap between the price and the cost and being sensitive to what the customer really perceives as value. And going back to the customer is not just, doing a survey, but really observing what the customer uses, when he uses, how long he uses, and what he doesn't use, and what he doesn't need to use. Benchmarking of popular competition is not done on the table with statistics and specs, but with the customers who use the benchmark products, asking them why they prefer that compared to your product, and getting his perceived value that he gains over a product that you make. Understanding this then clearly identifies what is essential and desirable. And then one has to understand what the customer derives in terms of return on his investment from the product over the year. What is he sensitive to? Is he sensitive to service? Is he sensitive to output? Is he sensitive to the productivity that his machine can give on the field? What is he sensitive to when he rates products? Understanding that, those features only are retained which provide him enhanced capability to derive better benefit on his scale of 1 to 10 of what is good and what is bad. Various principles and methods which were outlined in this webinar are very relevant to real life examples, and companies can derive hard real life profits and customer loyalty if they follow this. Thank you.
Thank you, Mr. Prashant. It was thought-provoking, nice. Yes, Mr. Umakant, please go ahead.
Yeah, good afternoon, everyone. First of all, I would like to thank Mr. Ganesh as well as Mr.Mrunal on giving a very nice overview on the design for value as well as design for cost. And as Mr. Shriram said, the entire process of product development starts with the customer. And here in Whirlpool, we believe that entire process is charted out as a customer to customer. So it starts with customer. Then we understand the needs of customer, we translate into design specification, and then we develop the product and then manufacture it, and again it goes to customer. So the entire cycle of the product development, it starts with customer and it ends with customer. And basically when we are focusing more and we are giving a value to customer, we need to consider a couple of points. One is how we are adding the value to customer in terms of understanding the entire reliability of the product, and then we are using some of the tools such as Six Sigma, as Mr. Ganesh as well as Mr. Mrunal mentioned, how effectively the different tools we can use it while driving the entire product development process. Into my experience, I worked in most of the product development process. So if we use the effectively these different tools as a designer, then definitely that will get added. And in fact, if we see the market of consumer durables, then nowadays the customer is very particular about the electronics, much of electronics going into the product, and in that case specifically we need to make sure to give the value to the customer, as well as at the same time we have to reduce the cost. And as a designer, if we more focus on how effectively combination of tools if we use it, and that will definitely reduce the overall cost. Now with that, I definitely agree with the Mr. Shriram as well as Mr. Prahsant was mentioned. SSA is doing an excellent job arranging these webinars where people are across the various industries. They will get use of what are the different tools can be used and how these tools can be effectively leveraged at the different stages. Down the line, going to remain in the competition, this is very much essential to have the proper tools, and that proper tools needs to be used at the appropriate stages so that we can have a value addition to the end customer. So with this, I would like to thank Mr. Pradeep for giving me the opportunity to present my view. Thanks everyone.
So yes, gentlemen, I thank you everyone. I thank Mr. Shriram, Mr. Umakant, and Mr. Prahsant joining us for this wonderful session. And thanks for your knowledge and thought-provoking ideas in terms of product cost reduction. So our next webinar will be announced very soon. So we are most likely to hold this Design Excellence Web Symposium that would be held on August 8th, and the final date for submission of papers is on July 7th. So you got another 30 to 40 days left. Yes. So thank you very much, gentlemen. Please do contact us if you have any suggestions. And thank you very much. Thank you all. Have a great day. Have a great evening. Take care. Bye.